My name is Dara McGowan. I'm a director in Partel. My main focus in Partel is the UK market, and the reason we're at the AECB show today is to demonstrate the membranes and tapes and adhesives that we manufacture and supply into the UK market. We were particularly keen on doing a hands-on activity today so that we can, I suppose, improve the practical application of the products that we supply. Yeah, so in terms of sustainability of our products and our approach to sustainability in Partel, we're trying to solve operational issues but also improve our embodied carbon as we do so. So we have a whole range of membranes and tapes, all of which have EPDs, but we're also improving the manufacturing process to improve those EPDs so that they have less of a carbon footprint. But I guess our main aim is to upgrade existing stock to build new buildings that last for a very long time. So our approach to sustainability is essentially durability. So when we're talking about durability and long-term performance of our products, whether that be the internal with the air tightness and vapor control systems or the outside with our breather membranes, it's really important that the specification of the product is appropriate for the application. So for example, at the start of today's presentation, I talked to the attendees about why we would spec one product over another. So we have a really wide range of membranes, some of which are suitable to be left exposed to the UV, for example, for a very long time, others that cannot be exposed for so long. So appropriate specification of product really helps with durability. So in Partel, we cover fabric materials by supplying airtight membranes, vapor control layers, breather membranes and things like that. But we also have decentralized ventilation systems which we design and distribute. The reason for that is when we make a building airtight, we have to adequately ventilate the project. So we want to not only improve the fabric, but also offer the solution for ventilation after the fact. It kind of brings it full circle, I guess, is what we're aiming to do. So in Partel, we have two what we call home markets. So we have the Irish and the UK, which are two of our home markets. And what that means is we have a director over each one of those markets, and we're committed to that market in terms of developing not only sales, but also technical support and development of contractor skills in those regions. So we spend lots of time not only manufacturing and supplying product, but also offering free technical support, hands-on training like we've done today, site visits, and that type of thing. And we will cover that in both Ireland and the UK. So in Partel, we sell all of our product in the UK directly to contractors. There's two reasons for that. Number one is it can help with pricing, but more importantly is the technical support that goes along with the product. So we want to set up a community where instead of buying it from a merchant, for example, you're buying it directly from us, which means you can email us, you can phone call, you can pick up the phone and call us, and you'll get an answer to your technical query. You can set up site visits, toolbox talks, and that type of thing. So we're really trying to back up the quality of the product with the quality of the service that's offered as well. So there are times where in Partel we wouldn't recommend to use vapor control layers, or sometimes a retrofit approach is not the right solution depending on the building type. We do lots of condensation risk analysis, and if the data is not there to support the product, we simply won't sell it into that application. We want to make sure that when we do sell a product, it's improving a building rather than having a negative impact down the line. So in the presentation today in the workshop, we first went through product specification. So after last year's AECB conference, lots of contractors and designers reached out to ask us to help with specification, and they wondered why we used one membrane type over another. So we looked at several different membranes from the Partel range at the start of the workshop today and discussed why each membrane is important and where it might be applied. After that, then we used some little training rigs to get hands-on with the product. So we really are encouraging contractors and designers to touch and feel the product, get a sense of how it works, how it's applied, little tips and tricks on the application process to improve quality on site. And that's really what we want to focus on today, getting product in the hands of contractors and designers. So like an EPDM, for example, would have an SD of like 2,500, 3,000 meters. It's super vapor closed. That one, as I said, is fixed SD, so it has an SD of 5 all year round. But when you change to the next membrane, that's another VCL, it's called Vara Plus. That has a variable SD. So that changes throughout the year depending on the moisture content of the wall or roof. So that has an SD of 0.5 meters up to 60 meters, depending on what the condition of the roof actually is or the wall. So essentially, as the moisture in the wall starts to climb throughout the year, if there's a leak in the membrane or something like that, this becomes more breathable and it allows reverse diffusion. So it allows moisture to come back into the building. That's the first question that comes up with any of the contractors I'm specifying product with. What's the difference between these two? They look almost the same. They're both VCLs. Isoperm Plus, because it's fixed SD, is more appropriate for new build construction because we know the outer layer is breathable, so we don't need reverse diffusion. We'll make sure that the external side is completely vapor open. Whereas in retrofit projects or in flat roof systems, sometimes the outside is not as breathable as we might like. You know, maybe we're keeping the render system on the outside and it's less vapor open than we'd hope. That's where you need the reverse diffusion. So I guess the range is fairly deep. We have new build products, we have retrofit products, and I'll help kind of specify one for you depending on the product that or the project that you're working on.
Are these both for inside?
They're both for inside, yeah.
Is this also more flexible than if you get climate variation?
Yeah, so we would use that one a lot. Like for example, our American clients would use that quite a bit, depending on what, like Florida for example, that can allow for reverse diffusion. So the pressure drive can switch direction throughout the year depending on the conditions.
In some cases, the emphasis might be more on reverse diffusion.
Exactly, yeah. So if it is a climate that, if the climate keeps going the way it's going in Ireland and the UK, it might become a case where we're 50-50 with reverse diffusion. So the vapor will always move from an area of high vapor pressure to an area of lower vapor pressure, right? So basically, traditionally in Ireland and the UK, we're losing more moisture from in the building to outside, showering, cooking, all that sort of thing. But the Vara Plus does allow vapor to move in the other direction as well. And in some climates, we have to allow it to switch throughout the year because as the... Yeah, even in new build. So sometimes if the vapor pressure is going to switch direction, we have to be allow that reverse diffusion to occur.
In retrofit, where you put in a project where you might have a potentially solid wall.
Yeah, it's always going to be that one. Yeah,
dry out.
Exactly, exactly. Now the rule of thumb would be for 99% of retrofits, I'd be going for Vara Plus anyway, just because it gives that extra level of, you know, there's more capacity to dry than with the isoperm. So normally I'd lean towards that anyway. We'll model that in Woofy as well. So if you're doing a retrofit project and you want to see what the wall build-up, how it performs from a moisture management perspective, we'll model all of that and we'll help spec a product based on the results of that model as well.
Are there downsides to a product like this then?
No, so basically the rule of thumb is you can always go from isoperm up to Vara Plus. That's a higher spec product in terms of its SD values. But for example, if I was to use isoperm plus where I should have used Vara, that could be problematic. So it's always safe to go up in spec. There's no issue with that.
Can I just say, when you say you would be, what if you're say doing a job in York or you're doing a job in sort of Scotland, completely different climate?
Yeah, so Woofy takes that into account. We use a.
Do you have a database big enough?
Yeah.
To do that?
There's climate files in the Woofy database, so we can pick a location. We'll pick the closest location to the project. If we need to generate specific data for that location, we can do that as well. Yeah.
The way John Moorhead does that with PHP or whatever,
Yeah.
you do that for Woofy too.
You can do, yeah. Now, honestly, there's normally a location close enough already, but you can generate bespoke climate data if you
But
need
if you've
to.
got like an elevated site, whatever, that's
It's a good question as well.
close to another, like a weather station or whatever.
Yeah.
That maybe is a good distance below it or whatever.
Yeah.
In that situation, what would you do?
So anytime we do a model, we model it in worst case scenarios. So we pick the worst orientation, whether that be from a driving rain or a sunlight perspective. It depends on the location. We'll always make sure that there's plenty of tolerance built into the model, that if it's close to failing, in our mind it's already failing. So it's kind of, at some point you have to make some assumptions for modeling. There's always going to be that issue. But we'll always go for worst case scenarios. So we model it as fully exposed. You bring up a good point. So I often get people come to me and say, look, can you have a look at this for me? I've got a condensation risk analysis done by whoever. I'll leave the names out, I'll leave that to Jeff. They would always use a glacier method, which is a simplified method of condensation risk analysis, whereas we'd use Woofy, which is dynamic. So it's just a much, we take a lot more detail into, not us, the software itself has more parameters that it can account for. That's the issue. So it passes when you use Glacier, but when you model it in Woofy, it'll fail in most cases.
Glazier's like a 60-year-old calculation, steady state
Yeah,
calculation.
exactly. like there's assumptions built into that software where it has to be completely waterproof from the outside, completely vapor closed from the inside, which we just know is unrealistic. Whereas we'll build in a level of absorption from moisture from outside. We manually input what level of air tightness we're aiming for. Again, we'll put some tolerance. If you're aiming for 3, we'll model it at 5. If you're aiming for 1, we'll model it at 3. Just to give that extra level of buffer zone, let's say. None of that can be modelled into glacier methods, so that's why we don't use it.
And I guess you also have the issue that you may have a localized leakage issue, although the overall air tightness might be,
yeah,
pretty good.
Yeah.
That could be generally great work in lots of places, but a weak spot.
100%, and it is worth saying that's kind of a limitation of WFI. It takes one wall build-up, it looks at that build-up. There are other parameters that aren't accounted for. So let's say, for example, if the render system cracks on the outside and there's an extra leak coming in, we can build that in if we want to, but at a certain point you're building in so much you're guaranteed to fail.
But isn't that the whole premise about retrofit? You're supposed to repair that before you
Exactly.
actually do that. So in terms of specification, that shouldn't be the issue.
Yeah.
But at any point that could break.
It could happen anyway.
Exactly.
But that would be the same anyway, whether you had whatever product.
100%. Now, what we would always do is WFI. Another difference between WFI and the glacier method. Glacier methods will tell you it's a pass or a fail, whereas WFI, it doesn't. It spits out like 50 graphs and we have to analyze the graph. So it's not yes or no, it's levels of risk.
Yeah.
So we can say, look, the wall is drying out really well. There's a capacity, even if there is a leak, that can still dry out over time once it's repaired. There's a lot more flexibility, it's a lot more detailed than your glacier method.
Have you looked at any studies where you're putting like probes into walls or anything like that?
Yeah, actually at the AECB conference last year we presented on a building, we're still modelling that. So we have a project in Wales at the moment. We've done all the WFI work. Andy Simmons was the architect on that, and Tim Hulse, I thought I saw him knocking around, he's here somewhere. He was the contractor on that. We've done all the WFI work and we built in monitors into that, so we're constantly monitoring it. So we're just coming up on a full year on that. So I'm not sure you'll have the data on it. We haven't put together a report on it yet.
Okay.
But we do a lot of that to make sure that what we're modelling is reflecting what's actually built.
You've actually got interstitial probes buried
Yeah.
in the wall to kind of measure the...
Exactly, yeah. They're built in a different layer. You need to know the layer to look in. Some layers are less risk than others. We built them in at the layer that's most at risk.
That's a retrofit and extension project, isn't it?
Yeah, majority retrofit. They had to knock part of it, a previous extension, just rebuild that. So they didn't increase the footprint at all, but it's, mostly retrofit. We actually have a good webinar on that. But anyway, I'll keep moving on. It's supposed to be mostly practical here, so I'll get through this as quick as I can.
You have me here then.
The next two membranes are breather membranes. One of them is Exoperm 150 and the other one is Exoperm 200. That's another question I get asked all the time. Why have you spec'd one over the other? Exoperm 150 is it's a monolithic, both of these membranes are monolithic, so they're really high performance breather membranes. But 150 would be used in closed cladding systems. So if you have a closed rain screen system, if it's large cladding on the outside, that's perfectly fine. If you were going to have shadow gaps in between your cladding, if it's going to be exposed for a very long period of time, you have to switch up to the Duro. That has a much longer UV stability, which isn't really talked about but has a major impact on the performance of the membranes. And the last two then, I'll skip again very quickly through this because I don't want to keep you any later than you need to be here. The last two are more for off-site construction, so they're reflective membranes, so they'll actually improve your U value depending on where they're used in the build-up. So we'll do a calculation on the U values. If there's an air cavity adjacent to these membranes, they can improve the U value. Yeah, so it's interesting actually. Unventilated is best, partially ventilated is worse, and fully ventilated is the worst in terms of performance. Adjacent to these, it will still improve it, but you need to model those ethically, which a lot of people don't. So you're modeling a ventilated cavity as unventilated. It looks great on paper, but in reality, we know that's not how it's constructed. But the Structural Timber Association have clamped down on that. They released a document last month clarifying how cavities should be modelled, which we've been doing from day one anyway. So we're kind of happy to see that happening because you're not competing with others that aren't modelling fairly. So it does depend on, like for example, the first one is ISO, so that's for the inside. That would typically be adjacent to a service cavity. and give you a bump in the U value there as well. Mostly for offsite, so I won't bore you too much. We'll get stuck into the practical because I know you're listening to presentations all day. So if you want to go into groups of, I guess, if you three guys want to work here, and unless you're sick of working with each other all the time, so it's up to you, I don't know. So we'll put you three guys here, we'll put you two guys anywhere here. So basically what we're going to do, I tend to let people off and make mistakes and correct it as we go. I think it's probably a more interesting way to learn. I know you guys just want to get hands-on with the product anyway. So the first thing we'll do is take the membranes from the tables. We're going to staple them on the front of the frame. There's staple guns floating around there. Do make sure to mark holes and cut them for your pipe and your cable. And I'll come back and deal with sealing those up and dealing with the window frame and stuff like that after. Is that all right?